I scare you?
Oh no, we're talking about someone that's going to go on this trip with us.
Oh.
I think one of the chaperones don't want to be there.
Oh, I was like, I do? I was very confused. All right, so law of cosines problems. All right, so remember with these, we're given either side angle side or side side side. So we'll go through and let's start with number 6. B equals 35 degrees. A is 43 and C is 19. All right, so just for perspective here, we've got A, B, C, and then little a, little b, and little c. So the ones that we know, angle B up here is 35 degrees, little a is 43, little c is 19. Okay, how many triangles do I get with law of cosines? 1. Always 1. That was a trick question. Okay, law of sines is the one where with our side angle case, okay, you could have either no 1 or 2 triangles. Okay, with law of cosines, we always just have 1 triangle. All right, so I need to figure out about finding another piece here with the given information that I have. So I can really go about this with whatever, but since I already have A and I already have C, I'm going to go ahead and try to find B here, just so that I have all the sides taken care of. So B is equal to, or let's see, it's the formula is B squared is equal to A squared plus C squared minus 2AC cosine B.
Why can't we just do A squared plus B squared plus C squared?
Because it's not a right triangle. Yeah, don't do that. It won't end well.
I was about to say, holy cow, people would be like tiny.
So B is equal to the square root of A squared plus C squared minus 2AC cosine B. Alright, so I can go ahead and plug stuff in here. So the square root of 43 squared plus 19 squared minus 2 times 43 times 19 times the cosine of 35. Okay, if you do this all as one thing, parentheses are very important, so make sure you are careful there. Thirty. All right, so 30. Okay, so now this, I don't really recall this being an issue in Algebra 2, just the way that it was set out, but in this book it will become an issue. So at this point, we could use the law of cosines again, but the law of cosines tends to be a little more work. So I would say switch to law of sines now, because only thing I need are 2 angle measures, and so it's just easier. Law of sines is easier. So when switching, this is very important, to the law of sines, choose the angle with the smallest side length Okay, so in this case, which one is that going to be?
Angle C.
Okay, angle C. So I'm going to come down here and do the sine of C. Whoa. sine of C over 19 is equal to, and I'm going with the stuff that, well, kind of what I was given, but I'm going to go with B, okay, because I have both of those pieces. So the sine of 35 over 30. So then C is equal to the inverse sine of 19 sine of 35 over 30. $21. And then to find the other angle A, what do I need to do? Yeah, 180 minus 21 minus 35, which is 124 degrees. All right, so now I'm going to write all the pieces of my triangle down here. All right, so angle A was 124 degrees. Side A was 43. Angle B was 35 degrees. Little b was 30. Angle C was 21 degrees. Side C was 19. Okay. Does this triangle make sense?
Whoa. Threw me off. I forgot I could make her extreme.
Yes.
Okay, well, why does it make sense? Okay, that is true. And what else about their angles?
Yeah, 280.
Okay, maybe I should clarify what I'm looking for. The biggest angle has to go with the biggest side, smallest angle with the smallest side. Okay, that is why this right here is important. Okay, if you had chosen to do C first, you would have gotten an angle C of 90 degrees with a side length of 19. That means your smallest side had the biggest angle, and that doesn't make sense. Okay, that's just how it would have worked out. So that's why I said always pick the smallest side or the smallest angle, or the angle with the smallest side, because you're going to be finding the angle when you're going to do that. Okay, because if not, it will make your triangle not make sense. Does that make sense?
No.
What doesn't make sense?
I don't know. I just like calculating.
Maybe seeing another one will help.
Maybe.
Okay. Let's see. About number 10. A is 1, B is 5, C is 8. Okay, so this is a side, side, side case. So what should I do first?
Check if it
Draw a
works.
triangle.
What?
Check if it works.
And is it going to?
No.
No, it is not going to work because A plus B is not greater than C. 1 plus 5 is not greater than 8. So no possible triangle.
Pretty drawn.
All right. Let's go back and do number 8. So we're going to have B is, well, actually, hold on. We're going to do 12 instead because I want to do one that's side, side, side. 12, we've got A is equal to 9.8. I lied, we're not doing 12 because 12 is also no possible triangle. This is awful.
Just make up one. Let's
Yeah, I'm not very good at the whole making up problems thing. They usually don't work out very well.
I'll make one now.
I just meant they usually don't come out to actually work.
Oh, never mind.
My wife.
My marriage relationship.
Okay, we'll use the values from 22, but we're going to solve for the triangle. Okay, but 22 is an area problem, so it's not actually this. Anyways, wow, my handwriting, just ignore that. Okay, A is going to be 5, B is 9, and C is 7. So I want to find the angle values for each of those. Okay, so I can really find any of the angles that I want to here. It really won't matter. So which one would you like to find? A. All right, cool. A. All right, so I have A squared is equal to B squared plus C squared minus 2BC cosine A. And I need to get A, the angle, by itself. So I'm going to end up with A squared minus B squared minus C squared. Got to follow this here. Divided by negative 2BC. Okay, this is equal to the cosine of A. Okay, so I subtracted B squared, subtracted C squared, and then I divided by negative 2BC, okay, to get the cosine of A by itself. So A is going to be equal to the inverse cosine of A squared minus B squared minus C squared over negative 2BC. Okay, do we follow how I got A by itself? We're good? No questions about how A got by itself? No. We took the inverse cosine. Well, it gives the A by itself. Okay, if you don't like this method, then from right here, you can just start plugging in numbers and moving stuff over, and hopefully you know laws of math and you can get A by itself. I like to get A by itself first. Also, if you wanted to, I'm not opposed to you having this modified formula on your formula sheet. So, if you don't want it, you don't want it. If you want it, you got it. Alright, so I'm plugging in numbers. A equals the inverse cosine of 5 squared minus 9 squared minus 7 squared divided by negative 2 times 9 times 7. And I've kind of got to take y'all's word for it because I obviously don't have this one worked out.
That's at Walmart. He's asking a bunch of questions.
Always good.
So that's like 25, or it's 81 minus 49. Yeah, 49. So it's like 130. It's like negative 105 divided by negative 63. Negative 105 divided by, it's like point something.
Start something you can't put in your head.
A is 34 degrees. Okay. Alright, I'm going to go ahead and make my...
I can only see this side of Richard's face. He's like,
Alright, and then at this point, I can now use the law of sines. So, I'm going to use the smallest side first. So I'm going to do C. So the sine of C over 7 equals the sine of 34 over 5. Okay, there's still a chance that this is going to come out and not be the right order, but we're just going to deal with it. So C equals the inverse sine of 7 sine of 34 over 5. $52 degrees. Oh, that worked out nicely. And then angle B.
It's gonna be like 90 something, like 4.
Is that right?
I don't know.
even know.
Oh, shoot, yeah, I've got
Yeah,
it.
I know the math.
All right, and that makes sense, right? Biggest angle, biggest side, smallest angle, smallest side. So let's just say as a general rule all the time, even when you're not doing the, like, switching to the law of sines, always pick the smallest side to find that angle if you're given side, side, side. Okay, that way we're not, I mean, it still might, if you do it that way and it still comes out to the fact where you have such triangle that doesn't make sense, just don't worry about it. If we're all doing the same thing, our triangles are all going to look the same. Okay, so let's just do that, and it'll just make our lives easier. And I won't have to grade 18 different triangles, or 8 different triangles, I guess, technically. Cool. Do we need to see any more? Are we good?
I don't know if I'm good.
Good to at least try a couple. All right, so in addition to what I gave you on Friday, I'm going to give you 5, 9, and 11. Okay, also, it is important that you know which type of triangle it is, because when we get to the test, I'm not going to tell you, use the law of cosines to find, or use the law of sines to find. I'm going to say solve the triangle. Okay, so make sure you know the different types and all of that, what's what. Okay, I'll even go so far as to let you have what h is equal to.
What is it
B sine A.
Oh, B sine A.
I'll let you have that on your formula sheet. I'll let you have, I'll even let you have how many no, I'm not going to let you have how many triangles it is. You just need to know that. Because there's going to be questions that probably say, tell me how many triangles, and I want you to actually have to know that. So you can have the formula for H and things like that, but you can't have, like, H equals A is blah, blah, blah. H less than A less than B is blah, blah, blah. You can't have that. Cool. All right.